Yes, I'm serious. Today we are going to do 20s, what's that called? Non-elementary integrals, and they are getting harder and harder. So be sure you need to watch this video carefully, and some questions will be really difficult, and they are very crazy. Let me just. Before we start some non-elementary integral, first we're gonna talk about some. Wait a minute. I'm ready for some tissue. Here is some tissue, and then we're gonna erase the pen. I'm going to erase them soon, so I need some tissue. And then here, before we start the non-elementary integrals question, let me just memorize these 13 integrals formula. And they are both non-elementary functions, and there are some special functions. And the first one is the integral of e power of negative x squared dx is equal to square root of pi over 2 times Yao f of x plus c. And Yao f of x is just a Abel function. It's called Abel function. And number 2, the integral of e power of x squared. We don't have a negative here. Be careful. It's equal to square root of pi over 2 stays the same, but here is e r f I of x, and it's called the imaginary error function. And plus c. Number 3, the integral of e power of x over x. If this is x over e power of x, and it can be integrated. Elementary, but e power of x over x can be integrated. And the special function is called ei of x plus c, and not just ei of x, not the plus c. And ei of x is called the exponential integral. Number 4, the integral of 1 over ln x is equal to li of x, not ln. Be careful. Li, and this not the imaginary number, and this is called the li function, and it's called logarithmic integral is called plus c. Number 5, the integral of sine x over x is equal to si of x, and it's called the sine integral. Number 6, the integral of cosine x over x is equal to ci of x plus c. And what about the integral of tangent x over x? And unfortunately, tangent x over x, we don't have a function yet. Or you can use some series to solve the integral of tangent x over x, but I haven't seen a YouTubers done that. Right? I think x tangent x, e power of x times tangent x, they can be integrated, even not elementary, or they are really hard, and I don't know. And number 7 and number 8 are the new formulas I've discovered in Wolfram Alpha. I just randomly type some random integral, and Wolfram Alpha give me this called the SHI, and it's called the hyperbolic sine integral. The integral of sinh x over x is equal to SHI of x. And sinh is the hyperbolic sine. And here is the fun one. What is the fun? What's the fact? What is the integral of sinh t over t dt? Type your answers. What are the results you're gonna get? Just know. Just Don't use the variable t when you do this integral, like sinh t over t. It will be very, very horrible. Your teacher will punish you if you do this integral with the variable t in your school, like sinh shi of t. You know what I mean, bro. So the number 8 integral is this phi ch. This actually phi if you use the t as the variable. The integral of cos x over x is equal to chi of x, or you can pronounce this as chi as she. I'm serious, it's she. An integral of cos x over x is chi x or chi, and this chi, up to you. And number 9, psi, and this is called a hyperbolic cosine integral. And number 9 is the integral of psi of x squared is equal to square root of pi over 2. We need a constant here, and the 2 is contained in the square root. Be careful. It's square root of pi over 2 multiplied by the Fresnel S integral. The S is called the Fresnel S integral, S of square root of 2 over pi x plus c. And Wolfram alpha, if you type this integral on Wolfram alpha, it will give you a result, the constant. And be sure the constant is square root of pi over 2. The 2 is inside square root. And number 10, the integral called cosine of x squared is equal to the same, but this time we're gonna use a c here. It's called the Fresnel C integral. And the hardest one might be this. And remind you that what's the integral of tangent of x squared. And tangent of x squared, it doesn't have the answers too. Just tangent is a very, very weird function. Like this integral of square root of tangent next, keyword of tangent next, they actually have the answers. Elementary. But tangent of square root of x doesn't have the answers. But also square root of psi x and keyword of psi, they don't have the answers. Elementary. And this is very weird. And tangent. And tangent of x squared, you can type this graph, type this function on the internet, and its graph is really weird. And you can check that out by your own. And number 11, the integral of ln of 1 minus x. And this one is, if we don't have a 1 and a minus sign here, and this can be integrated. But this time it's ln of 1 minus x over x. And here we can get the result is negative li2 of x. And this time it's not the same as this logarithmic integral. And this the big letter one, we're gonna get negative here. And then be sure you write 2 here. Big letter li of 2, and it's called polylogarithm integral. This is called a polylogarithm. And remember, just remember this negative. Be sure we have negative and put 2 here, and this is form. And Wolfram alpha give you the form is li2 of x. We need a negative here. And then number 12, the integral of square root of 1 minus a sine square x. And here a is a constant, just any constant. And even 0, I think it might be okay. And the integral of square root of 1 minus a sine square x in this form, we're gonna get e of e. This it's called the elliptic integral, I think. And this elliptic f, I don't know what it's called, but is e. How to pronounce this is e of this angle. We're gonna put an x here and then put a vertical bar and then a, this constant. Be sure it's a negative in front. If this is positive, you're gonna change it to negative minus of negative a, and then the result you're gonna put is negative a here. The c and 13 this time is different, and 1 over square root of 1 minus a sine square x is equal to f, the elliptic f of x a, x vertical a. Or how to pronounce this, I don't know that much, but I like to pronounce this as e x a, and then e of x a, f of x a. Just stop it. So let me just start with our integral. If you want to copy this formula, you can pause the video. You can go back to the video, just go back to 20 seconds ago and then pause the video to take a screenshot. So the integral we are going to do today, the first integral, let me just write it down here. And the number 1, from easy to difficult. I don't know, you guys can see, right? I think you guys can see. And then the first integral is just our e power of ex. And this is very indeterminate, right? So to integrate this, first we're gonna use up that u is equal to e power of x, right? E power of x is our best friend. Differentiate it, you get itself back. Just du will be our ex dx. So du is just equal to our u, or u dx, right? And then dx is just equal to what? Let me just isolate our dx divided by u on both sides. This is e du over u. Just show you some step, because this the first question we're gonna do. And this e, and the e power of x is u, and then divided by u, right? This is equal to du over u, and then e power of u du, and it's just our ei of u, exponential integral. And this ei, and then our result is e power of x plus c, and that's it. And number 2, let me just do the easy one first. ln of ln x. They are both really popular non-elementary integral, and people they are really scared about this integral because they are very hard to integrate, right? And then, but if you use some non-elementary functions, special functions, and it will be just and then the integral of ln of ln x. And here I'm going to use our DI method, integration by part. And then we let our u is equal to ln of ln x, and then our v is just multiplied by 1. Why? This one is kind of ugly, you know. Di, and then to do this integrate 1, you get x, and then differentiate this. First you get 1 over that, right? 1 over that, and then multiply by the chain rule inside, you get 1 over x. So 1 over x ln x totally, and then the product of this is the first part of the answer. First part of the answer is the American access. X times ln of ln x, and the minus the integral of this, and the x and x, they are cancelled. So you get only 1 over ln x dx here. And here x times ln of ln x, and then minus the integral is just our logarithmic integral, and it's called li of x plus c. And number 3 is just our sinh of e power of x, from easiest to our hardest. And sinh of e power of x is our substitution. Once again, we're gonna let u is equal to our e power of x, du is equal to e power of x dx, best friend method, and then forget our dx, and then dx is just equal to du over u, and this is just sinh of u divided by u du, right? And then this function sinh u, this integral sinh u over u is just our shi sinh of e power of x plus c. That's it. We can do one more integral here, and then we're gonna erase them. And number 4, integral of what? Let me show you. Si of x, the sine integral. And whenever there are only one function, we always just use our integration by part. We're gonna differentiate si of x and then integrate 1, just like that. And then integrate 1, you get x, and then differentiate si of x, you get sine x over x, right? Because the integral of this is just that. So this time that you get x times si of x, and then minus x and x, they are cancelled. They cancel each other out, so you can get sine x. Let me just pronounce this as cancel each other out, and it will be more convenient to me. And then the integral of sine x is negative cosine x. So negative and negative, they become positive. So this is plus cosine x plus c. So here's the first number 4 question, and they are really easy for now, and I'm really honest, and it's easy now, but later they will be very lazy and hard. So our number 5 is our integral of sinh x over x squared. Yes. Whenever you see 1 over x squared, integrate this 1 over x squared, you get negative 1 over x. So this is our DI method. Sinh x and then integrate 1 over x squared, and this is really good. Negative 1 over x. And then to differentiate sinh x, you get positive cos x. So this time that become negative sinh x over x, and then this time that negative become positive, and then this integral is just sinh cos x over x dx. So our result is just negative sinh x over x, and then this integral is just our ci of positive ci of x plus c, and that's it. However, this is wrong. This is totally wrong. This is cos of x. Be careful. I know this integral many of you just haven't seen, but let me just type here. This is just plus chi. It's called chi of x plus c. And then yes, it's the answers. And then the number 6, the integral. Can you guys see? I think you guys can. And the number 6 integral is the integral of our above function. There are only one functions, so just use our DI method. We're gonna differentiate E out f of x and then integrate 1, you get x. And how to differentiate E out f of x? And here is the note here. In our note, we know the integral of e power of negative x squared dx is equal to what? This is equal to square root of pi, and the 2 is not contained in the square root, be careful. And then multiply by e out f of x. This is a negative version. You're gonna use the normal above function e out f of x. And here, what can we do next? Here, if you differentiate square root of pi over 2 e out f of x, you will get what? How can we get the e minus x squared here? Just we should have a e power of negative x squared here, right? And then how can we cancel the square root of pi over 2? Yes, it's just our 2 over square root of pi, right? So they can cancel each other out. Square root of pi and square root of pi, and then 2 and 2, you will get this result. So differentiating this, you get what? Let me give you some time to think. Yes, this is just 2 over square root of pi, right? And then you differentiate this, you get that, right? No, integrate this, you get that back. So do this time that you get x times e out f of x. And then 2 over square root of pi is a constant, put it outside the integral, and then this is just x times e power of negative x squared dx. And then, so what is this right now? What's this integral? And this is an elementary integral. And let me just do it here. When you differentiate e power of negative x squared, you will get e power of negative x squared. And then you're gonna multiply by the square root of this, you get negative 2x. So original, you just bring the negative 2x inside and then get a plus. Here you will get plus 1 over square root of pi. And then negative 2x e power of negative x squared dx is just this, right? So you will get a positive here. Plus 1 over square root of pi or e power of negative x squared. But that's our answers. So let me just erase. Number 7. When we reach question 10, I'm going to eat some snack and then drink some water because I'm really thirsty right now, and my mouth is really bitter. And then we're gonna do the integral of this is fun. This is a fun one. EI of x squared. EI is the exponential integral, you know. And do this integral. You know, integrate e power of x over x, you will get that EI of x, right? DI, we're gonna use our integration by part because there are only one function here, EI of x squared. We're gonna just differentiate EI of x squared and then integrate 1. Integrate 1, you just get x. And then do that, you get e power of something, right? E power of something and then over something. But you're going to multiply by a chain rule of this, you get 2x. And then you see this time that x times x, and then this and this. X squared and this, they are cancelled. So you will get x times EI of x squared, and then put the constant outside the integral, minus 2 and then times integral of e power of x squared. We just get x squared. And this time we don't have a negative here. Be sure this integral is just equal to square root of pi over 2, and the imaginary error function ERFI of x. We are not going to add up plus c yet because we're going to cancel something. So you get x times EI of x squared minus square root of pi times ERFI of x plus c. Yes, that's our answers. And then our number 8. Number 8 is a crazy one. This is kind of hard, I think. ln x multiplied by Li of x. Wow, this is torture, man. We know the integral of ln x really well, but we don't know the integral of Li of x. So, this is our integration by part once again. di put a d and I, we're gonna integrate ln x and then differentiate Li of x. And then differentiate Li of x, this is really easy, 1 over ln x. And this. And if you don't know what's the answers of the integral of ln x, this is just x times ln x. And this is the famous one, the integral of ln x. You should remember. If you don't know the integral of ln x, you just need to use the DI method and then differentiate ln x and then integrate 1, so you will get that. So do this by your own, and then the first part of the answers is just this time that, right? So this is x times, let me just follow each other as the question. Just this is ln x times Li of x. Let me just put a parenthesis and it will be easier to read. And then people will not think that x is inside the Li. No, the Li of x is inside the ln. So put the parenthesis, it will be more safe. And then minus x times Li of x. And then we're gonna 1 over ln x multiplied by this inside. ln x and ln x, they are cancelled. So you will get the first part of the answers. No, first integral. Let me split it to 2 integrals. The first one is easy. The integral of x. Sorry. And number 2. This time that it become positive. The integral of x times x over ln x. And this is also now elementary. X over ln x. You will see why. And let me just finish the integral of this. ln x of Li of x minus x times Li of x. And this integral is just add 1 to the power and then divided by a new power. You get 1 over 2 x squared. And then this integral, let me just use our use up. Let u is equal to ln x. Du is just equal to 1 over x dx. And then here, dx is just equal to what's ratio on one side, you get x is equal to e to the u. E to the u, right? So this is e to the u du. So you will get our x is what? X is e to the u, and then multiply by this e to the u, get e to the power of 2u over, yes, u du. Oh, this is just our exponential, right? Exponential integral. EI of minus 1/2 of x squared. Whenever you see this, just put down my EI of 2x. 2, and then what's our u? Just ln x. 2 EI of 2 ln x, just add a positive. If you differentiate EI of 2u, you get e power of 2u over 2u, and then multiply with chain rule, you get 2, multiply by 2, and you will get that. You can check the answers by yourself, and then the answers is just EI of 2 ln x plus x ln x times Li of x minus x Li of x minus 1 over 2 x squared, and that's our answers. Don't forget about the plus c. The order doesn't matter, doesn't really matter, just that, crazy. they are getting harder, right? Crazy. Crazy, man. The number 9. Number 9. The integral of ln of inverse cosine x dx. And please do not put the -1 because of the ln property. Just put the negative sign outside. But this the most distinct notation. Power of -1. I think this is the most distinct notation in mathematics, and it's called the inverse cosine. And also the sine and the tangent. Just this not 1/cosine x. So be careful. Don't put the power outside. I think this integral we're gonna start use up once again, right? U is equal to inverse cosine x. And then I'll get our original back, you get cosine u is equal to dx. Differentiate both sides, you get negative sine u du. Don't write down dx. And then this time we're gonna write dx here. And then here, the integral of, put a negative sign here, and then cosine u. Yes, minus sine u, and then ln u, sine u ln u. This integral is also non-elementary, sine u ln u, like this. We're gonna use our integration by part. We're gonna differentiate ln u and then integrate sine u. Integrate sine u, you get negative cosine u, and then differentiate ln u, you get 1/u. So you're gonna get this time that, but in front we have negative, so it's become positive. Let me write as cosine u ln u first. I think don't put down parentheses, it's okay. It's cosine u ln u, and then this time that become positive, and then in front we have negative, so this minus the integral of cosine u over u du. So total you get cosine u ln u minus this is the sine, the cosine integral ci of u. And what's our u? You know cosine u is just our x, and then u is just our inverse cosine x, right? And then our u, once again, ci of inverse cosine x plus c. Yeah, that's our answers. Number 10. After I do this question, just eat some snack. Oh, this is a fun one. X power of ln x dx. And as I mentioned on my previous video, and we have already integrated this integral in our previous video, and this is also an elementary integral, but I'm not going to just put the answers here. Just I'm going to do some step. Still do some step. I don't think x to the x can be integrated, even in elementary. I think we need to use some series, but that will be crazy. Just to do this integral, we're gonna let u is equal to ln x, right? X power of something, and then du is equal to 1/x dx. Or you can just raise c on one side and then just differentiate both sides. And then dx is just equal to x du. Just put down the answer space e on one side, just e to the u du. So this x is just e to the u. And then ln x is just raised to another u. Raised to another u, just multiply the power, you get u squared. And then multiply by e to the u. Let me just add the power up, you get e to the power of u squared plus u du. And this integral, and u squared plus u, and this, let me just ignore the u here first. What's the integral of e to the power of u squared? And it reminds me some this called the imaginary error function, right? So why don't we just compute the square? So let me just compute the square. You get this square, right? So we just need to compute the square like this. Let me just lay that so you guys will see. Compute the square. First you get x u. Let me use the variable u. U square plus u. I'm going to take out 1/2 of this coefficient, take half of this. The one time you get 1/2 and then square that. But don't forget to minus this square again. This will change the whole thing if we don't subtract that. Negative 1/2 square. So you get u plus 1/2 and then square and then minus 1/4. Let me just put down the answers. The result, the integral of e power of u plus 1/2 square and then minus 1/4 du. And then e to the power of this minus this. We can write this as e to the power of this and then multiply by e to the power of negative 1/4, right? Because it's a constant, so you can just put it outside the integral. And then e power of negative 1/4 is what? 1 over e power of negative 1 over e power of 1/4. So you can write this as e power of 1/4, but I like to write it as the 4th of e, up to you. And then this integral, just let w is equal to u plus 1/2, and then dw is just equal to du. So it doesn't really matter, just get the square root of pi over 2 ELFI, the error function of the inside. We don't have to do the chain rule here. So overall, let me just combine to square root of pi times ELFI of our u is just lnx plus 1/2 over 2 times the 4th of e plus c. And that's it. Oh, that's crazy. Oh, we have so many to go. Never indeterminate this tan integral. Tan integral are also long. Never underrate them. under what? I don't know what it's called. My foot is kind of. So I'm going to drink some water. Number 11. Let me eat some snack. Marshmallow. Number 11. The integral of the parallelism Ly2 of x dx. This integral we just get the function alone, so we're gonna use our integration by part. We're gonna differentiate Ly2 of x and then integrate 1. Next, we know that integrate ln of 1 minus x over x, we'll get a negative Ly2 of x over x. So we shall you need a negative here. So we'll get that positive. So this time that it becomes where x here first. X times Ly2 of x. And then x sides they are cancelled. So plus the integral of ln of 1 minus x. This. So ln situation, I like to use a DI method once again. We have only a function, one function. ln of 1 minus x, and then integrate 1. You get x. Differentiate this. First you get 1 over that, and then multiply the chain rule, you get negative 1. So this time that it becomes x times ln of 1 minus x. And this time that become a positive, and then integral of x over 1 minus 6 dx. So this integral, let me just minus 1 and add 1 on one side. You see what happened. I'm going to split it to two integrals. 1 minus 6. And first, x minus 1 over 1 minus 6. Let me just factor out the negative side. And then you just get negative times 1 over x. 1 minus 6 over 1 minus 6. So you just get 1 here. Be sure you have negative 1 dx. And then 1 over 1 minus 6. Just get positive integral of 1 over 1 minus 6 dx. So ladies and gentlemen, just one question. We need to use the whole white board, not blood. You get x. And then here, we just need a parentheses here. ln of parentheses of 1 minus x, because you see this, we don't have absolute value here. And then don't forget about the chain rule. You're gonna get negative 1. So we're gonna get a negative here. And don't forget about the plus c. And we are done. Yes, that's our answers. Here's the number 12 question. Number 12. The integral, and this is a little bit easy. This is easier. Don't need to use our DI method, integration by part. And here, I'm going to, we have an x here. I'd like to cancel out the x. What should we do? Yes, we let u is equal to x squared. If we differentiate this, you will get 2x. So this is cancelled. So du is just equal to 2x dx. And then here, we don't have a 2x here. Let me just give it a 2 and then multiply by 1/2. So this is 1/2. This is not titration. Be careful. I write kinda ugly. The integral of x squared sine of sorry, my fault. So 1 over 2. You just get 1 over 2 here. And then 2x dx, they are combined to du. So you just get a sine. And then x squared raised to the second power, you get this, right? So this is the integral of sine of u squared du. And this is just our Fresnel S integral. First you get 1/2 and then multiply by the square root of pi over 2. And then s of 2 over square root of pi, and then our u is what? X squared plus c, and that's it. This is really easy, but compared to the other one. Number 13. This is the inverse sine x over inverse, not tangent, not inverse tangent. The inverse cosine x dx. So be careful. Inverse x over inverse cosine x is not equal to inverse tangent x. If you change it to inverse tangent x, you know inverse tangent x can be integrated. But this is the non-elementary integrals video. So why put this integral here if this is equal to inverse tangent x, right? So here, cosine is a function. This is, they are at, let me just draw a triangle here. And this is a right triangle. And let me just put a random, this is inverse x. So theta is just equal to inverse x, right? So sine theta is just x. So sine theta is equal to x, which is x over 1. So this is hypotenuse over, no, opposite over hypotenuse. And then this is just inverse x, you get that, right? And this is just inverse cos x. This is just adjacent over hypotenuse, you get that. They're adding up to 90 degrees. So inverse x plus inverse cos x is equal to 90 degrees, but this is integral. We're gonna use pi over 2. This is a radian. So inverse sine x, we're gonna change it to pi over 2 minus inverse cos x. Just change the order. du dx, not du. So what should we do now? Split to integral. Pi over 2 is a constant, put it outside integral 1 over inverse cosine x dx. Minus inverse cosine and inverse cosine, they are cancelled. You just get a 1 here. What's the integral? 1 over inverse cosine x. And once again, this is not equal to inverse secant x. Be careful. Inverse secant x can also be integrated, but not 1 over inverse cos x. This is not acceptable. So to integrate this, let me just use a u-sub. Let u is equal to inverse cos x, and our original cosine is equal to x. Negative sine u du is just equal to dx. So you get pi over 2 multiplied by, put a negative outside, and then this is just u, right? Multiplied by sine u du minus x minus x minus. So this is just our SI of u, right? The answer of this integral is pi over 2 multiplied by SI, and then the result is inverse cosine x, right? Wait a minute. What thing I do? The answer is not this. Wait a minute. Use up. Do I do it one? Let me figure it out. What? Let me just check Wolfram Alpha. Wait a minute. Do I type the answer wrong? Wait a minute. Let me just differentiate this. The Wolfram Alpha doesn't give me the result of this. Let me just try to differentiate this. Pi over 2 pi over 2 times SI of inverse cosine x over 2, and then minus our x, right? Do I make some mistake here? Let me check. I don't think we make a mistake. Negative. Yeah, we don't. I don't put a negative, but to the effect result. Well, maybe I am wrong, but I will do this integral on my next video. Or maybe just I know if we do this question, this video will be too long. I know. Just skip this question. Wait a minute. Just so number 14. Let me just speed up. Number 14 is the hard one. The integral of e power of tangent x. And e power of tangent x. Let me try to use out. U is equal to inverse tangent x. And then get our inverse on one side. You get inverse tangent u is equal to x. And then 1 over 1 plus u squared is equal to dx du plus du here. Differentiate inverse sine u, you get this. So you get e to the u multiplied by this, right? 1 over, and then 1 plus u squared. Let me write as u squared plus 1. And this is, of course, an non-elementary integral. And I'm going to use some partial fraction here. And u squared plus 1, let me write as u squared, I squared. And the I squared, you know, is -1. And then be sure you need a negative sign here to get the original back. So u squared minus I squared is just a plus b, a minus b times a plus b. Doesn't matter. Let me just write it here. U minus I multiplied by u plus I here. Du. And then here, let me just write it as, this is a partial fraction. U minus I plus u plus I here. Du. Here, I'm going to use our cover method. And how can we let this to equal to 0? Now, u going to be I, right? Put I inside, you get 1 over 2i, and then cover it, you get negative I, and then negative I, you get negative 1 over 2i here, right? So here is the deal. We're gonna factor out the 1 over 2i here, and then put the integral inside, you get e to the power of u over u minus I du, and then subtract, right? Subtract another, just multiply negative 1 over 2i times the integral of e to the power of u over u plus I du. So here, I'm going to want a negative I here, and this to be a positive I. But this is, of course, is not the same as the original one. So we're gonna multiply by e to the power of I here, and then e to the power of negative I to cancel each other out. The reason of this is reminds us the exponential integral. If you let w is equal to u minus I, and then dw is just equal to d, it doesn't really matter, just put the ei of that. And then I don't like to be on bottom, I like to be on the top. Multiply by I and on the denominator and the numerator, and the I times I is just negative, so you get negative, and then I here over 2, and then multiply by e power of I, and then ei of u, right? Ei of u minus I, and then u is just tangent x minus I, and then I times I being positive. In front we have a positive here. Have a negative times negative being positive, and then I times e power of negative I over 2, and then EI of our U is just tangent x plus I, and this result is really weird, right? But this is non-elementary, so the question might be weird, and this is really normal. So number 15, we have some space here. The integral of inverse psi x dx. To integrate inverse psi x, take a square root of inverse psi x. And of course, it's not equal to psi of psi power of -1 half. This is the inverse function. Do this. Let me just let U is equal to the entire thing. Inverse psi x d. And then we're gonna square both sides. Square both sides, and then take a original. You get psi u the square that, and then you just take a original. It's equal to x. Differentiate both sides, you get 2u because of chain rule, and then cosine u square, and then it's equal to dx. Let me just put it here. The integral, the original is just 2u. I'm going to write it as 2u, 2 times that u, is, and then multiply by another u times cosine of u squared du. Right? So here, if you integrate this, if you differentiate this, you get negative sign, and then first to this u, multiply by chain rule of u squared, you get 2u. So we can use our integration method, and this is actually acceptable, right? Let's just use our DI method. This can be integrated. So use our DI method. Then we differentiate 2u, and then integrate u times cosine of u squared. Then we do this in our head. Let w is equal to u squared. dw is just equal to 2u dw. 2u du. W is equal to u squared. dw is equal to 2u du. Right? We don't have a 2 here. Give it a 2 and then multiply 1 half. You get cosine of a w, you get psi. 1 half of psi u squared. So right, and then differentiate this, you get 2. Okay. First part of the answers, you get u times psi of u squared, and this time that it becomes, they cancel each other out, 2 and then 2. This is just psi of u squared du. So this is just, this integral is just our square root of pi over 2 inside, the 2 is inside, and then not e out fi. Multiply by the s of square root of 2 over pi of our u, and then what's our u? Psi u squared is just our x, put it here, and then multiply by the square root of inverse psi x. And then minus square root of pi over 2, s of 2 over square root of 2 over pi, and then u is just our inverse square root of inverse x, and that's okay. Put a multiply notation, that's okay. Yes, that's our answer. 6 more to go. 5 more to go, not 6. They are getting harder and harder. You see, wow, crazy. And then last one is the hardest one among this. It's really crazy. The hardest one, last one. Number 16. Integral of square root of sine x dx. Remember, we have a formula which is called cosine of 2x, right? Cosine of 2x, we have three forms. One is cosine square x minus sine square x, and there are three forms. We're going to use the form of 1 minus 2 sine square x. And that form is because the integral of square root of 1 minus 2 times a constant times sine square x is just equal to e and the integral bar of something. So I'm going to get a cosine here. What should we do? Yes, we have a formula. It's just cosine of pi over 2 our angle. This is our cosine. Okay, sorry. Cosine of pi over 2 minus x dx. We want a cosine, right? Cosine of 2 times something, but be sure you want to get an original value. So 2 multiplied by pi over 4 minus x over 2 du dx, not du. So you get square root of 1 minus 2 sine of something, 2 sine, and then pi over 4 minus x squared over 2x. And 1 over 2, 1 minus 2 sine square of something. We have a negative sign, so be sure you just get e here. Square root of something, right? Square root of 1 minus, right? So here is the trick. Just get here and here, and then get a 2 here. But what should we put here? Here is the trick. Let w is equal to that. And then look, the derivative of inside, negative 1 over 2. Right, you get negative 1 over 2 here. And then do the reciprocal of this, you get negative 2. Because you need to move it to the other side, right? You just get a negative 2 here. So that's our answers. This look weird, but this our answers, just our answers. Number 7 is even more weird. Number 17, that's 7. The integral of 1 over square root of 1 minus x power 4. It seems like it's an elementary integral, but unfortunately, and this is not doable. This integral in our elementary integrals. Here, we're going to factor it. Let's just factor it as 1 minus x squared raised to the second power. Just raise. So here we will get what? 1 over square root of 1 minus x squared. Multiply, just split to 2 integral, right? Split to 2 square root. 1 plus x squared dx. Here, 1 minus sine x of something. I'm going to use our substitution. Let x is equal to sine theta, right? You get a cosine soon. So this will equal to cosine theta d theta. And the good news, you see, this is over, you get cosine theta d theta. And this is just square root of 1 minus sine square theta. Multiplied by square root of 1 plus sine square theta. You will see 1 minus sine square theta is just cosine square theta. Take square root, you get cosine theta, and this, they are gone. And then this integral, you can write this as 1 over square root of 1. The Fresnel F says we need a negative sign here, but this is a positive. So what should we do? You know, positive is equal to negative 1 minus, right? You get positive. Minus parentheses of sine square x, right? Sine square theta now, x. So just put down the answers. F of theta, and then vertical bar of 1. Negative 1, negative sign. And then our theta is just equal to the inverse. So this is inverse x. f of inverse x of negative 1. This is really such a weird answer, right? F of inverse x will equal negative 1. We are almost finished. 3 more to go. I'm going to check my paper, check my t-shirt. Wait me 30 seconds. This is really dirty. Okay. Let me just put down the integral first. This is my homemade integral. Cosine of inverse cosine square over square root of 1 minus x squared. This is really crazy though, but this is not as crazy as the last one. So wait a minute. Actually, don't need 1 minute. Nice. Just 20 seconds or so. It seems like it's really crazy, right? But you see, if you let u is equal to inverse cosine, you just get negative 1 over square root of 1 minus x squared. So why don't we just use our substitution? Let u is equal to inverse cosine x. So let me just get our original like this. Cosine u is equal to x, and then so you get no need to use square root. But I think the square root will be better. The square root, let me just use square root. Or even just write this down as this. Plus, and then du is equal to negative 1 over square root of 1 minus x squared. Yes, because this is the derivative of inverse cos x. So we don't have a negative, given a negative, so outside you get a negative. And then cosine of, this is really easy, just very easy. Cosine of u squared du. This is just due to negative square root of pi over 2, and then the Fresnel c of 2 over pi, and now u is just inverse cos x. Not so bad at all. Number 19. I haven't seen YouTubers integrate this yet. Number 19. Number 19, the integral of ln of cosine x dx. And this can be integrated, right? But if you plus some, if this is a definite integral which goes to 0 to power factor 2, it will give you negative power factor 2 ln 2. But this time, this is a indefinite integral. So how we do this though? We're gonna change this into our imaginary world. So if you put this integrals question in Wolfram Alpha, it doesn't give you these answers, but the answers I write on my notebook when I differentiate this is actually just that. So let me just change into our imaginary world. Because as you know, this is equal to, this is our Euclid's formula, or this is form, just really famous, e power of ix plus e power of negative ix over 2. Here you get the integral. It's the ln property. Ln of this over this, you get ln of this and then minus the ln of this. So integral of ln of e power of ix plus e power of negative ix minus the integral of ln of 2. This. How will we integrate this though? You know, ix is really easy to integrate, right? just I over 2x squared. So let me just factor out the e power of ix here, and then plus 1 power of, how can we get negative ix here? Just minus 2ix, right? You will get that. And minus this, you will get ln2, put this a constant and put an x. Be sure you need a parentheses here, because this is not equal to ln2x. This is ln2 times x. So, by the lab part of the property, you will change ln e power of ix. You just get ix, right? Integral of ix dx. By the add, right? ln of 1 plus e power of negative ix dx. And the minus ln 2x. Here, just very easy. I over 2 x squared. ln to the power and then divided by new power, and then I'm going to bring this to here. Minus ln2 times x. And this integral, you know, ln of 1 over ln of 1 minus, let this variable to be t or something. Over t, you will get negative ly2 of t plus c, right? So I somewhat want a negative here. So let me just use our substitution. Let u is equal to our negative e power of negative 2ix. So our du will be equal to e power of negative 2ix, and then multiply by this, because our chain rule you get 2I dx. And now dx is just equal to 2I over, you need a negative here. Because you just move the side, you get a negative side here. And then du 1 over that. I don't need to be on the bottom, multiply by I and multiply by this. At the same time, you get negative become positive. So I over 2u du. You need to do this really fast. Just simplify it really fast. Just like me. I over 2 is a constant, put it outside. I over 2 times ln of 1. This is u is just our minus u, right? Over our u. So this is just our answer is I over 2x squared minus ln 2 times x plus, but be sure this is a negative, because if you integrate this, you give you negative li2 of u, right? So be sure positive and negative become negative. I over 2, and then li2 of our input is just u is equal to negative e power of 2ix plus c. I think that's the answers. Just do that. Very answers, right? And number 20 is the hardest one. The craziest one. And this is also my homemade question. This will be crazy, very crazy. The result might look kind of short, but number 20. I'm going to leave some space here. The integral of ln x multiplied by 1 plus sine squared x minus x sine x cosine x over, this is not elementary, over 1 plus sine square x power of 3 over 2 dx. Oh. Usually when I see ln x, we like to differentiate this because this is really easy, just 1 over x, right? And if we let u is equal to this, it will be very hard to differentiate, right? I'm not going to differentiate this. It will be too crazy. So let me tell you, this integral is possible, but with this ln x, and this is non-elementary. an elementary integral question. So let me just use our DI method. DI for the we're gonna differentiate Lnx and then integrate 1 plus psi square x minus x psi x cosine x over 1 plus psi square x and then power of 3 over 2. Of course, we can just put down the answers here. So differentiate this 1 over x, just 1 over x. So we're gonna do another integral, just do another integral, the integral of 1 plus psi square x minus x psi x cosine x over 1 plus psi square x 3 over 2. Whenever you see a 3 over 2, you might think some add 1 to the power 1/2 and then add 1 to the power, right? So the only situation is a square root of something, right? Square root of this and then over 1 and then add them, you just get 3 over 2, right? But how can we do this? Use a quotation rule. First you get square root of this and then divided by another 1. Add them to be 3 over 2. The first step, you see, you can just, this is power of 1, right? So let me just factor it to 2 fraction. You see what happened. Over 1 plus psi square x power of 3 over 2 minus the integral of x size. If this is impossible, it won't be my channel, right? Won't be this in this integral in this video, right? So power of 1, right? Power of 1. Just subtract the power, you'll get what? 1 minus 3 over 2. Complete the 2, you get 2, right? 2 and then 2 minus 3, you get negative 1/2. Negative 1/2. So it's just 1 over that. So this is just 1 over square root of 1 plus psi square x this. I'm not going to do this integral first. I like to do this integral first. So let me try to differentiate something. Try to differentiate 1 over square root of that, because you need to square root. First you get square root and then divided by 1/2. Square root and then add the power to be 1. So what about this situation? What square root of 1 plus x squared? First you square that 1 plus psi square x and then this time the integral of 1, the derivative of 1 is just 0. So and then you're gonna subtract and then 2 in the derivative of this, you get 2 over square root of 1 plus psi square x and then multiply by the derivative of inside, get 2 psi x cosine x. You see what happened? 2 and 2 they are cancelled, and then this 1/2 this power become negative psi x cosine x. Wow. 1 plus psi square x power of 3 over 2 dx. No dx. Because this is, and also don't put down plus c here because this is a derivative question. So what do we do? Just use our DI method. But do we have a space here? Let me just put down the result of this. Negative psi x cosine x over this. So I'm going to use our DI method. Use our DI method. We're gonna differentiate x and then integrate. What's this called? integrate psi x cos x over this 1 plus psi square x. Here we don't have a negative here, so be sure you will get a negative sign here. Differentiate this you get 1 and then this you get negative psi, no, negative 1 over square root of 1 plus psi square x. So overall, but wait a minute to us. No. But I think I do some. If this is a positive sign and a negative time, that's these two integral will be cancelled. Right. Oh, we have a negative here. Negative time negative. Let me just shut up. I need to shut up here. And the minus. Minus and minus become positive, right? Plus x over, this is the first part of the answer, psi square x. And then negative times negative become positive, but in front we have another 1 over square of 1 plus psi square x dx. And of course, you see, this integral and this integral, they cancel each other out. One is positive and one is negative. So this integral is just x over square root of 1 plus psi square x plus c. Yes, but we are in the DI method, so we don't need to put a plus c here. And the result of this integral is just our x over square root of 1 plus psi square x. I think you can put this, if you are a teacher, you can put this question in your final exam, and it will be very cool, very cool. You see the cancellation of this integral. And okay, we are not finished yet. And this is elementary, but we add a ln x here, and it will be elementary soon. So why do I erase the negative? Erase the equal sign. I'm just kind of. So here, the first part of the answers, we get x times ln x over square root of 1 plus psi square x. I don't think we can simplify here. Just leave these answers. And the minus. Wow. I see this integral once again. But this is called a non-elementary integrals video, right? So this is also non-elementary. And do this question look really similar? Yes, we have a positive sign here. We're gonna change it to negative and then negative. Let me just put down the answers for you guys. Square root of 1 plus psi square x. So minus, and then this is just f, 1 over square root of that, right? F. We don't need a parentheses, just f of minus f, because we don't need to use our substitution. Just minus f of the inside and then quotable bar of -1, and we are done. Wow, that's crazy. Well, x times ln x over square root of 1 plus psi square x minus the f of x quotable vertical bar of -1. Let's see. Whew. And that's really cool. Before we just cancel this integral and that integral, they cancel each other out, but this time we have to do this integral once again. You see, that's very fun, right? Of course, if we don't have an ln x, you can integrate this integral in an elementary way. So that's our videos. Hope you subscribe to my channel, and please comment down below what's your favorite question and the weirdest one and the coolest one, and let me give your opinions of yours, and peace out.